So here we take the example, same like of we have taken all the already example of 4-band resistance. So same way we take the example of 5-band. So here you can see that first band, that is a green color. Green color has a 5 value. Second color band, that is a red color, and that has a value 2. So this is the second digit. Third color band, that is the orange, that has a value 3. So this is the third digit. So 5, 2, 3. And fourth band, that is a yellow color. Yellow color has 4 value. It means that this 5, 2, 3, that is multiplied with the 10 raised to 4. And last band, that is a brown. So brown has a 1% tolerance. As you can see in this table, brown color has tolerance 1%. In fourth band, 1%. If it is a 4-band resistance, then 5-band, fifth band, they have also same value of tolerance. So here the value of this 5-band resistors, that becomes 523 into 10 raised to 4 plus or minus 1% variation. So what is the 1% of this value? This is a 5.2 mega ohm. 5.2 is 0.523 mega ohm. So subtract this value from 5.23. So you get the minimum value 4.707 and maximum value, add this 0.523 in this 5.23. So you get the maximum value 5.753 mega ohm. So your resistance can vary between 5.707 to 5.753 mega ohm. So by this way you can identify this value of the 5-band. I hope it is clear to all of you. Clear? So I give you some of the example for this. So find out the value of this resistance. The first color is blue, green, black, orange, and gold. So what is the value of this resistance? Can anyone give me the answer? What is the value of blue color? All of you will write up.
6.
6 number. Very good. Then green has
5.
green has
5.
5. Okay. Then black
0.
0.
0. Then orange
3.
3.
3. So here orange has 3 colors. So it is a multiplier. Yes or no?
Yes, sir.
6,500 plus minus 5.
So what is the value of this resistance? 650.
6,500 plus
650 into 10 raised to 3. It means this is 650 kilo ohm. Yes or no?
Yes, yes.
Yes, sir.
Yes, sir.
650 kilo ohm plus or minus how much variation?
5.
Gold
Five,
color
five.
means 5%.
5.
Yes, yes, very good, very good. So it is 650 kilo ohm plus minus 5% variation. Clear? So this is the answer of this first question. Same way, yellow, white, red, silver. What is the yellow color number?
4.
4. Yes, very good.
48.
Then white.
9.
Yes.
9.
Red color.
2.
2.
10 raised to
10 raised to power 2.
10 raised to 2. Okay. What is the value?
4900 plus minus 10%.
Yes, very good. 4,900 ohm plus minus 10%. Yes.
10%.
Then this third, brown, black, brown, silver. Brown has
1.
100.
10 raised to 1.
1 0.
1 0 1.
1. Black is
Plus minus 10%.
yes, very good. So answer is 100 plus minus
Plus
10%.
Plus minus 10%.
All of you clear? Is there any doubt in this?
Yes.
Okay, okay, very good. Okay, same way, exactly opposite. Based on the value of the resistor, identify the color of the resistance. So first is the 10 ohm plus minus 5%.
Brown, black, black, brown, black, black, gold.
Brown, black, gold.
Yes, very good, very good. Brown, black, black, gold. So first digit is 1, it means it is brown. Second digit is 0, it means it is black. There is no third digit, it means that is multiplied with 1. So when you get the multiplier 1,
10 is to
then
0.
you multiply with 10 raised to 0. Clear? So when you get the 10 raised to 0, when you have color of black. Clear? 0 for black color. In the third digit, you get 10 raised to 0. So it is brown, black, black. 5% tolerance, it means gold color.
Gold.
Okay, so answer is brown, black, black, gold. Very good. Second, 850.
Green, yellow.
Gray, green, yellow,
silver.
silver.
Yes, very good.
Silver.
Yes, yes. 8 value means what? That is a gray color.
Gray.
5 means that is a green color. How many 0? 4 0. It means 10 raised to 4. So 4 value is with the yellow color.
Yellow.
So it is gray, green, yellow. And 10% variation means silver color. Clear? Same way, this third value.
Black,
Violet, black,
Violet,
Violet, black,
green, gold.
blue, violet, black, blue, gold.
What is the seventh color?
Black,
Seventh color has
gold.
violet color. Okay.
Then 0.
Then second is 0. It means it is the black.
Black.
And then after how many 0? 6
Black.
0. So it is 10 raised to 6.
Blue.
So 6 number is with the blue color.
Yes.
Yeah. So it is purple, black, blue, and gold.
Gold.
Clear, all of you?
Gold.
Yes, sir.
Okay. So these are the for your self-study. Same way, identify the value of this register based on color coding, and same way based on the value, find out the color coding of the registers. Clear? So this is for your self-study. Then we go for the next point, wattage rating of the resistance. So what is the wattage rating of the resistance? As you know that each and every resistance has some power rating. So what this power rating indicates? So this power rating of the resistance that indicate that the maximum amount of power that resistor can dissipate without being damaged. Okay. So suppose I am saying that one resistor have 1 watt rating, it means that that resistor has maximum capacity to dissipate 1 watt power without damage of that resistance. So that is the wattage rating of this resistance. And this value of wattage or power rating of this resistors, that is not related with the ohmic value. It means that is not dependent upon the resistance. Whatever the value of resistance, power rating may be different. Then what is the wattage rating? It decided based on the physical size and the shape of the resistance. That means if the size of the resistance is large, its wattage rating is large. So that is mainly determined by the physical size and shape of the resistance. So you can see here some of the pictures of different wattage rating. You can see that very small type of the resistance. These are the watt rating is 1/8. Then more than this is a 1/4 wattage resistor. This is a half watt resistor, 1 watt resistor, 2 watt, and 5 watt resistor. So you can see that as the size of resistance is increases, its power rating is increasing. It means that resistance is capable to withstand more power, but without is called as a rating of the resistor. Then, as we know that the area of the resistance is large, they can dissipate more power. So, what is the area of this resistance? So, area of resistance is nothing but length of resistance, then multiply with the circumferences. So, C is the circumferences and L is the length. So, this indicates the area of your cylindrical space resistors. So, based on that, you can identify the wattage rating of this resistor. So, generally, as we see the 3 fixed type of the resistor, first is carbon composite resistor, which are generally the smallest size of the resistor. So, they have wattage rating is very small, between 20 milliwatt to 1 watt, because their size is very small. Then second is wire wound resistor, that generally is large in size. So they have wattage rating between less than 1 watt to several hundred watt. Then third is that has is changes. Then what are the factors that affecting the value of resistance of the resistor? So as you know the equation of resistance, R is equal to rho L by A. So rho is what? That is the resistivity of the material. So based on the material, the resistivity of this resistance will change. If you have copper material resistance, aluminum resistance, so all this material has different value of the resistivity. So you get the different value of the resistance. So first parameter which change the or affect the value of resistance, that is type of material. Clear? Then second parameter is L. L means length of resistance. So as the length is large, the value of resistance is large. So this is the second factor which affects the value of resistance. And third is area. As the area of resistance is large, the resistance value is here small. Clear? But as length is large, the resistance is increased. So this is the third parameter, cross-sectional area. And fourth parameter is temperature. So as the temperature increases, your resistance value will be changed. That increase or decrease, that depend upon the type of material. If conductor material, then variation is maybe different. If it is an insulating material, then they have different value of resistance based on the temperature. So we will say that we will see after the next slide that how the value of resistance is changes based on the material and based on the temperature rise. So this is a basic four factors value of the resistance. So what is the temperature coefficient? Anyone know that what is temperature coefficient? Yes, anyone?
So the change in temperature with respect to its original resistance and temperature.
What this temperature coefficient indicates? What? Suppose I am saying that it is a positive temperature coefficient. So what is the meaning of this?
Relative change in physical property.
Change in physical property. How?
Relative change in physical.
How it change the physical property? Change the change the length area by changing the temperature. Yes. What is meaning of positive temperature coefficient and negative temperature coefficient?
The temperature coefficient means it changes the physical properties associated with the resistance.
What is the physical property? There are two properties, length and area. So change the length or area by changing the temperature.
So positive temperature coefficient means it increases with resistance, means temperature increases with increasing resistance.
Yes, very good, very good. So positive temperature means positive temperature coefficient means what? As the temperature increases, the resistance of the resistor will increases. That is called as positive temperature coefficient. Means that is directly proportional with the value of temperature. Clear? Exactly opposite negative temperature coefficient. It means what? As the temperature increases, the resistance of the resistor will decreases. Clear? That is inversely proportional. Clear, all of you?
Yes.
So temperature coefficient indicates that what is the relation with the value of resistor with the temperature rise or fall. So that is indicated by the coefficient. Temperature. Negative temperature coefficient, it means that resistance value is inversely proportional to the temperature. Clear, all of you? All of you clear?
Yes, sir.
Yes, sir.
Okay, now any doubt up to this? Okay. Okay.
No, sir.
So we go for the next topic. So what is the application of resistance? So generally, as you know that we use the resistance to limit or reduce the current. Clear? Another application is that we divide the resistance, we divide the voltage to produce the desired voltage across particular element. Suppose we require the 220 watt, but we have 250 watt input resistance. So by putting the resistance in series with that element, we can provide the 220 watt across the device by changing the resistance. Okay, this is another application. Second is that generate the heat in certain cases. So by the resistor, we can generate the heat. Some of the application we require the heat as an output. So that place you can use the resistor. Here, same way like your example is like your heater. Clear? So electric heater is what? That is a one type of high value of resistor. So as the electricity flow through them, so that produces a large amount of the heat, and that will hit the water. Clear? So this is the application of using the resistor. Clear? So as we already discussed that the value equation of resistor R is equal to rho L by A. So this value of the resistance that is directly proportional to the length of the material, inversely proportional to the cross-sectional area of the material. Then third is depend on the nature of material. It means this resistivity of the resistor that vary based on the material which we use as a resistor. Copper has different resistivity, aluminum has different resistivity, nickel has different resistivity. So third parameter is the value of resistor depend upon the nature of material, and fourth is depend upon the temperature. As the temperature is rise, maybe resistance is rise or maybe resistance decreases. That is depending upon the material we use. Clear? So there are four different parameters that will decide the value of the resistance. So let's discuss the different types of material. So first is the conductor, second is insulator, and third is semiconductor. Okay. So what is called as conductor? So obviously, as per the name, the conductor means the electron through this material can be easily flow. That type of material is called as a conducting material or called as a conductor. So it is the material which has a large number of free electrons so that current can easily flow through it. જે પણ મટીરિયલમાં કરંટ છે easily flow થઈ જાય. So that type of material called as a conducting material or called as a conductor. Clear? So the material, all the material which has a resistivity less than 10 raised to minus 8 ohm into meter, that type of all the materials behaves as a conductor. Again repeat, all the materials which have a resistivity less than 10 raised to minus 8 ohm into meter, that is a unit of resistivity, that type of material behaves as a conductor. So what is the example of this type of material? Like silver, copper, aluminum, carbon, and almost all type of metals that have the value of resistivity less than 10 raised to minus 8 ohm into meter. So all these metals behaves as a conducting material. Yeah. Same way, what is the insulating material? Exactly opposite to the conductor. The material in which the electrons or current cannot be easily flow, that type of the material is called as a insulating material. So if the outer electrons in the periphery of outer electrons of a material which very tightly bound to the nucleus, so that becomes difficult to remove this type of electrons from the orbit. So this type of the material is called as an insulator. So if these outer electrons cannot be easily removed from this orbit, so this type of elements, very small amount of the current can be flow. So hence the current cannot flow through this material easily. So this is the called as an insulator. So all the material which has a resistivity about 10 raised to 5 ohm into meter, that type of material that is behaves as a insulator. What is the example? So first example is mica, same porcelain, glass, oil, and rubber. All these are the insulating material. So in this type of material, current cannot be easily flow because they have high value of resistance. Clear? Then semiconductor. What is called as semiconductor? So in this type of material, which outer electrons are bound to the nucleus, but this electron can made free by some means. Means if you apply external energy to this outer orbit electron, then this electron can be freely moved. So this type of material we not called as a conductor or we not called as a insulator also. So this is a combination of conductor and insulator. So that's why it's called as a semiconductor material. It is not a full conductor or not a full insulator. So it is called as a semi-conducting material device, in which electron cannot flow easily, or it is also not difficult to flow this electron. So this type of material we can get by adding some impurity into the pure metals. So we get the semiconductor type of the material. So all the material which has resistivity between 10 raised to -8 to 10 raised to 5 ohm into meter, it means between this conducting material resistivity and insulating material resistivity, between that, if you have the resistivity of the material, then you can say that this is the semiconducting material. Generally, we use this germanium and silicon as a semiconductor material. Mostly, you can see in the diode, which is a one type of semiconductor device, in which we can use the germanium and silicon material based on the requirements. So diode is a semiconductor material because we use the germanium and silicon. I hope it is clear to all of you what is the difference between conductor, insulator, and semiconductor. Is there any doubt up to this? Anyone?
Yes, sir.
Yes, any question?
Yes, sir. If we are talking about differences in terms of valence band and conduction band between these three materials, how will we differentiate?
Valence band and?
Valence band and conduction band means the gap between.
Yes, obviously, in the conducting materials, the gap is very small because conductor can easily flow from one band to other band. Yes, that's why it is called as a conducting material. So obviously, in the conducting material, the gap is small. Same way, exactly opposite in the insulating material, the gap is large because electrons require high amount of energy to transform from one band to another band. Clear? So the band gap is large in insulator. Same way in the semiconductor, the gap is not too large or not too small. Clear? So that type is called as semiconductor material.
So the gap can be changed in semiconductors.
It means
the distance between the two bands.
Yeah, that we can change, but by that depends upon how much energy we can provide it. Suppose here you can see that what is a semiconductor material? It is the electron in the outer bound. The electrons in the outer orbit that is bound with the nucleus. But if you provide the external energy, then it can freely move from one band to another band. So for that, you provide the external energy. If you require the conduction in the semiconductor material. As you know that the diode is a semiconductor material. Okay. So when your diode will conduct, at how much voltage? How much voltage your diode will start conducting? Suppose you apply the voltage across the diode, anode positive, cathode negative. So when diode will start conducting, or where current is flowing from this diode, after how much voltage? Start from zero voltage. Yes.
There
is some threshold value is required. Yes or no?
Yes.
As you know that silicon material.
Electron volt.
Yes, if a diode is made up of silicon material, then you require threshold of 0.3 volt. Clear? If it is germanium material, then you require 0.7 or 0.6 volt. It means you have required some threshold voltage across the two terminal of the diode. After that, current will start flowing. Clear?
Yes, sir.
So it means that semiconductor material requires some external energy to move the electrons from one band to another band. Clear? But that is not required in the conductor. Suppose if you apply the same voltage in the conducting material, the current will start from the zero voltage. Clear? Because they are not require any external energy because there are large number of free electrons are available in the conductors. So that not need any external energy to flow the electrons. Clear?
Yes, sir.
All of you got this answer? So this is the main difference between conductor, insulator, and semiconductor. I hope it is clear to all of you. So we go for the next topic, that is the temperature coefficient of resistance. So I think all of you familiar with this topic also. So what is the temperature coefficient of resistance? Yes? Yes, any doubt?
No, sir.
Okay. So let's start this topic, temperature coefficient of resistance. So almost all the resistors material, that value is changes with respect to temperature. As we see that, suppose that R0, that is the value of resistance of a material at a 0 degree Celsius. RT, that is the resistance of material at T degree Celsius. So whatever the difference in this resistance, by changing the temperature from 0 degree to T degree, that we call as a delta R, change in the change in the resistance, which is RT minus R0. So generally this value of change in the resistance, that is directly proportional to the initial value of resistance. Initial value of resistance means resistance at 0 degree. So at 0 degree, what is the resistance? R0. So this delta R, that is directly proportional to the R0, it means initial resistance, and it is also directly proportional to change in temperature. So change in temperature means T minus 0. So it is T. So you can see that delta R, change in the resistance, that is directly proportional to R0 into T. R0 is initial resistance and T is the temperature difference. T minus 0, or you can write also T2 minus T1, whatever temperature you can take. So what is delta R? Temperature resistance difference, RT minus R0. So put this delta R, replace this delta R by RT minus R0. So this equation becomes RT minus R0 directly proportional to R0 into T. Clear? Then after equalize this equation and multiply with the constant alpha. So this equation becomes RT minus R0 equal to alpha into R0T. So what is alpha? So alpha is nothing but a temperature coefficient of resistance. So if it is a positive, it means it is a positive temperature coefficient. If it is negative, it means the resistance material has negative temperature coefficient. So different material has different temperature coefficient. So variation of this resistance with change in the temperature of any material, that is governed by this property. So based on that, you can make the equation of alpha. So from this equation, the alpha equation becomes alpha is equal to RT minus R0 divided by R0 into T. So you can see that this is the first equation. So this temperature coefficient of resistance alpha, definition is says that this is defined as the change in the resistance, it means RT minus R0 per unit rise in temperature. So you can see the denominator is T, the temperature difference. So that is per unit rise in temperature per ohm original resistance, it is R0. Again, repeat the definition of temperature coefficient of resistance alpha. It is defined as change in resistance RT minus R0 per unit rise in temperature per ohm original resistance. This is called as temperature coefficient of resistance alpha. Then usually this temperature coefficient we generally measure at particular reference temperature, and generally this reference temperature is always a 0 degree Celsius. So based on that we calculate alpha. So it is called as a alpha 0 because we calculate this coefficient at reference temperature of 0 degree Celsius. So generally we write in the equation alpha 0 because we measure it at a 0 degree Celsius. So it is denoted as alpha 0. So after that, if you rewrite this equation, so this first equation that becomes RT minus R0 equal to alpha 0 into R0T. So after the simplification, the equation of RT, value of resistance at temperature T, that becomes R0 into 1 plus alpha 0 into T. This is the simplification of the equation number 1. Or you can say that same from this equation also. Okay. So you get this equation. So if you have the initial resistance at 0 degree, if you have alpha 0, and if you need to find out the value of resistance at new temperature T, so you can apply this equation and find out the value of the new resistance. Because as the temperatures change, value of the resistance will changes. So this equation, the calculation of examples. So remember this equation. You can also note down this equation. So let's derive the equation, how to calculate the new value of the resistance. based on the temperature difference created. So suppose that standard temperature at 0 degrees Celsius, material has a resistance R0 ohm. Then at T1 degree Celsius, suppose it has a resistance R1, T2 degree Celsius has resistance R2 ohm. So based on that, we have the value of resistance R1 at T1 degree is equal to R0 into 1 plus alpha 0 into T1. Same way at T2 degree Celsius, resistance R2 ohm. So we have value R2 is equal to R0 into 1 plus alpha 0 into T2. So if you have R1 and if you have this temperature T1 and T2 alpha 0, so you can calculate the value of this new resistance R2 at the T2 degree. So you can see that by taking the ratio of this both this equation R2 divided by R1, R0 is cancelled out. So based on the T2, T1 and alpha 0, you can find out the value of new resistance at degree of T2. Same way, suppose if temperature coefficient alpha 0 and R0 is not given in the example, then the relation between non-resistance RT1 at temperature of T1 degree and unknown resistance RT2 and T2 degree Celsius, that can be found by this way. So for that we calculate the new resistance. So how to calculate this? So alpha T1, that is a temperature coefficient of resistance at T1 degree or T1 Celsius. So the value of this alpha, that is equal to slope of the graph divided by resistance at T1 degree Celsius. So what is the meaning of slope of the graph? So slope of the graph, you can see here, as the temperature is increases, the resistance will increases. So that is, I'm talking about the material which has a positive temperature coefficient. So this is a graph of positive temperature coefficient resistance. Generally, you in the all the type of metals, you get this type of graph. As the temperature increases, resistance will increase. So you can see that initially at 0 degree, here temperature is R0. At T1 degree, at T1 temperature, resistance is RT1. At T2 degree, temperature is RT2. So what is the value of alpha, temperature coefficient? So the value of temperature coefficient alpha, that is what? Slope of the graph divided by resistance at T1 degree Celsius. So slope of the graph is what? Slope of this graph is what? AB divided by BC. What is AB? AB is nothing but difference between RT2 minus RT1. And BC is what? Temperature difference, T2 minus T1. So as you can see that this graph, slope of minus RT RT1, and based on that you can calculate the value of RT2, that is a new temperature, resistance at new temperature T2. So you can see here this RT2 minus RT1 comes here, then this T2 minus T1 multiply with this alpha T1 into RT1, so that becomes this. After simplification, you can make the equation of RT2. So based on this equation, if you know the temperature difference, if you know the initial value of resistance at T1 temperature and temperature coefficient, then you can calculate the new value of the temperature, new value of the resistance at temperature of T2 degrees Celsius. Same way again, if you simplify this, take the RT2, RT1 common, so you can get this new equation of RT2. So this is the equation you have to write down, which will help you during the calculation of the example related to this. So I hope you understand how to get these equations. Is there any doubt up to this? Anyone? Yes, anyone doubt? Anything?
No, sir.
Okay.
No, sir.
Okay.
No.
So first in this table, we identify that how the value of resistance is changes with temperature based on the different materials. So first is the metal type of materials. So in the all the metals, the resistance of pure metals are generally that is increases with rise in the temperature. means all the metals has positive temperature coefficient of resistance. All the metals like copper, aluminum, all the pure metals. Clear? They have positive temperature coefficient. It means as the temperature of this metal increases, the resistance of the metal will increase. Clear? So this is called as positive temperature coefficient. And this increase in the resistance with the temperature that is very large, as well as it is a regular increase in the temperature. So there is no any irregularity with the change in the temperature. This increases the resistance with the temperature in a regular manner and in a very large manner. Clear? So suppose if you change the temperature suddenly from 5 degree to 50 degree, so suddenly the value of the resistance of this metal will increases in a regular manner, in a directly proportional manner. So what are metals? Copper, aluminum, all these are the metals which have positive temperature coefficient. Then alloys, which is a combination of two metals or two materials. So this type of materials or alloys, that resistance is increases with rise in temperature. But what is the difference with the metal? Here the increase in the resistance with temperature that is irregular and small. It means suppose you suddenly change the temperature from 5 degree to 50 degree, it will not suddenly increase the resistance up to that level. It means change in the resistor with change in the temperature that is irregular and very small. Clear? So this type of material, alloy type of the material, it has a low value of the positive temperature coefficient, because by changing the temperature, the value of the resistance will change in a very small amount. That's why it is called as a low value of positive temperature coefficient. So generally the nichrome, which is a one type of alloys which has a low positive value of temperature coefficient, which is made up of nickel and chromium material. So all the alloys has no value of positive temperature coefficient. Then insulator, semiconductor, and all electrolytes. So all these materials, in all this material, the resistance is decreases with rise in temperature. Exactly opposite to the metals and alloys. So as the temperature increases, resistance is decreases. So it means that they have negative temperature coefficient of resistance. So insulator, semiconductor, and electrolyte, that has negative temperature coefficient of resistance. Alpha is negative. So as the temperature is increases, what will happen in this material? Number of many free electrons are created. So it means that current can be easily flow through them. So resistance, it means decreases through this material. So resistance is dropped as the temperature is increased. So this type of material is like rubber, oil, plastic, all these are the material which has a negative temperature coefficient of resistance. I hope it is clear to all in which material has positive, negative, and low positive temperature coefficient of resistance. Clear all of you up to this?
Yes, sir.
Okay.
Yes.
So here I stop this lecture, but before that I give the one example for work. Example, the wire. And what will be the resistance of wire? So this example I give you for homework. And the next lecture we will calculate this example and I give the answer of this. But before that, you find out the answer of this example. So next lecture, we will calculate the number of examples related to the resistance, resistivity. So all of you please take with the note and pen as well as calculator. So it is easy for you to calculate the examples. Clear all of you?
Sir, how can we download this PPT?
Yeah, I will provide you this PPT.
Okay.
So first lecture PPT I already provided to you. I think all of you got this. But then I first lecture.
Yes, sir. Yes, sir.
Okay,
Yes, sir. Yes, sir.
Okay, same way I will provide the PPT for the lecture also. Okay.
Okay.
So here I stop this lecture. Okay. So join in your next lecture.
Sir, will it be 27?
Yes.
Sir, is it 27?
No.
I will give the answer of the next lecture. You calculate first all. Give you the procedure how to calculate it. Okay. All of you clear?
Okay, sir.
Sir,
Yes.
I have a doubt.
Yes,
Sir,
bolo.
in the question, it will be given that it is a 5-band resistor or 4-band resistor.
In which?
The previous topic of the calculation of the resistance.
Example ની વાત કરો છો?
No, sir. Yeah, the example. Suppose the question is 5, 3 and 4 times 0. We have to find
Yes.
the resistance.
Hmm.
Then will it will given or it is a 5-band resistor or 4-band resistor?
Yeah, it is given. It is given that it is 5-band or 4-band resistance.
Okay.
Okay. But if it is not written in the example, then a 4-band resistance. Example, you assume it is a 4-band resistance because I am not writing here is a 4-band or 5-band.
Sir, but
Yes.
it is given 5%, 10%. It is in only gold and silver. No. If it is 5-band resistors, then the red also will be given.
No. Whatever band
No.
resistor, 4-band or 5-band, tolerance is remain same for gold and silver. Here.
No. Okay.
It will not change. Here in the table, this table I have written that is for 4-band resistance. But the same value of tolerance you get if it is a 5-band resistance.
No, sir. If it is 5, 3, then 4 times 0, then the third digit we take as the third color, or we take as it the multiplier. I'm asking that way. If it's not given, then it can be.
If it is
both
not
ways.
given, it means it is a 4-band resistance. That is a common sense. Okay.
Okay.
If it is not given, it means it is a 4-band resistance. But generally it is not specified, then you assume it is a 4-band resistance. Clear?
Okay. Yeah.
Clear all of you? Okay, so here I stop this meeting. So you can leave this.